Alright guys, welcome to 2.1 linear equations in two variables. This is for Math 0314. The first thing we're going to talk about today is the Cartesian plane. This is the Cartesian plane. This is just essentially the XY plane. And this was created by a famous mathematician named Rene Descartes. It's pronounced Descartes, hence Cartesian plane. Don't say Descartes. And what Descartes did was he was able to extrapolate mathematical equations into a graph. So he was the guy who kind of came up with the idea of putting in graphing an equation. And so what we want to know about this is that if we live in the quadrant 1, this is considered quadrant 1, what happens is when I go to the right, values are positive. And when I go up, values are still positive. So everything in this quadrant is positive, positive. However, if I go to quadrant 2, right, my x values become negative, but my y values are still positive. If we go down to quadrant 3, we're now going to see that both x and y are negative, and if we're in quadrant 4, my x value is positive and my y value is negative. So this is significant because if I give you points, like let's say I want to graph 3, 1, just by looking at 3, 1, I know I'm in quadrant 1. And we always do the x values first. So we go 1, 2, 3, and then we go up 1. So there's 3, 1. Okay, let's do another one real fast. Let's say I wanted to graph negative 4, 1. Because the x value is negative and the y value is positive, I automatically know I'm in quadrant 2. This would mean that I always go x first, so I go to negative 4 and then up 1. So there's that point. Let's say I wanted to do another point. Let's do this one in brown. Let's say I want to do negative 4, negative 3. Well, because they're both negative, I know I'm living in quadrant 3. I would go x versus negative 4, then y is negative 3. That would put me more or less right there. Now, one last example. Let's go with red. Let's say I wanted to give you 2, negative 3. Well, we know this one's in quadrant 4 because only the y value is negative. So what did I say? 2, negative 3. So I'd go to the right, down negative 3, and that would be right there. Okay, so encourage you to practice getting comfortable with plotting points. Shouldn't be too bad. One little slick way that I've seen of making sure that you know the order of the quadrants is the letter C. Okay, so we start C here and we draw it all the way around there. So hopefully that makes sense. Let's move on. Okay, so we're going to talk about linear equations, and we kind of mentioned this before. In a linear equation, it is of the format ax plus by equals c. The big thing I want you to realize is that the exponent in a linear equation of the x value has to be 1. Okay. This is more of what you're going to see, where they give you, this question is asking you to determine if negative 4, 0, 2, negative 4, and 1 and 10/3 is a solution. So all you have to realize is the first value is x, the second is y, and you just substitute them in. So if x is negative 4 and y is 0, then I get 8 equals 8, and that's true. Okay. If I try the next one, x is 2 and y is negative 4, let's see if I can fit that here. We get negative 2 times 2 plus 3 times negative 4. And we're going to see if that equals 8. This will give me negative 4 minus 12. We're seeing if that's 8. Clearly, that's going to give me negative 16, which is not 8. So that is not going to work, right? And the last one x is 1 and y is 10/3, so we'll have negative 2 times 1 plus 3 times 10/3. I'm going to see if this gives me 8. And so negative 2 times 1 is obviously negative 2. Here the 3's will divide out, so the fraction was kind of intimidating, but not really. And 10 minus 2 is 8, so 8 equals 8, and that's true. So this one will work, this one will work, but this one's wrong. So hopefully that makes sense. Let's move on to the next question. So, and this is more or less what the chapter is getting to, which is how do you go about graphing these? So one thing I want to stress here, if they're saying graph from points, there's a lot of different ways to graph these equations, but one of the ways is you can just plug in values. Knowing what the x-intercept is and what the y-intercept is makes this process very easy. So just remember the x-intercept is when y is 0, and the y-intercept is when x is 0. So all I do is I go through and I plug in y is 0, and this will give me 3x equals 15, so x is 5. And I'll do the same thing for the y-intercept. Plug in x is 0, and y becomes 3. So what this tells me is that I have the coordinate 5, 0, and I have the coordinate 0, 3. Okay. This helps me to graph it, so let me graph it off to the side here, because all I have to do now is plot my values. So 5, 0 means I go 1, 2, 3, 4, 5. And because y is 0, then it's just at 0. And 0, 3 means I start at 0 and I go up 1, 2, 3. So you can see the virtue of plotting these points, because once you do that, then you can connect the dots, and that's it. So this is what we're going to be doing for all these questions. So if you haven't done so already, try to graph for yourself 2x minus y equals 1, y equals negative 1/3 x minus 2, y equals 1/4 x. And these get a little more challenging, but x equals 3, y equals 3. I'm sorry, x equals 6, y equals 3, and negative 2y equals 9. So pause the video, run through that, try that on your own, and then we'll go over these together. So I'm going to assume that you guys have given it a go, and we're going to do these together. So again, I'm going to go ahead and just say x is 0. I'm going to solve for y. So y becomes negative 1. Then I'm going to redo this whole process over again. Let me rewrite the equation. I'm going to say y is 0, and I'm going to solve for x. So I have 0, negative 1, and then 1/2, 0. So now if I graph these, 0, negative 1 lives here. 1/2, 0 lives right here. And the line looks something like this. There you have it. So hopefully this is getting to be pretty simple. Let's look at C. So say x is 0, then I have y equals negative 1/3 times 0 minus 2, which gives me y is equal to negative 2. So if x is 0, y is negative 2. Let me rewrite it over here. So I give you y equals negative 1/3 x minus 2. If I make y 0, then negative 1/3 x minus 2 equals 0. So 2 equals negative 1/3 x. And negative 6 is x. So hopefully you're able to see that I just added 2 here. And here I multiplied by negative 3. Okay, so this, in any case, this gives me negative 6, 0. So let me graph it right here. This means that, oops, let me draw that a little clearer. So 0, -2 would live here. -6, 0 would live 1, 2, 3, 4, 5, 6 here. And my line is going to look like such. Okay. Now, D is the one that's going to be interesting, because if I say x is 0, I'm always going to get y equals 0. But if y equals 0, then if I make y 0, x would be 0. So in other words, if I make y 0, it would follow that x would be 0. So I've become a little redundant, and really all I'm giving you is the point 0, 0. So what do? Well, you just plug in another number. So if I'm just going to plug in another number, well, if the equation is, I'm running out of space here, y equals 1/4 x, what would make sense is not to plug in 1, but to plug in 4 for x, because that would just give me y to be 1. So 4, 1 would be another point. So hopefully that makes sense. I picked 4 because these would divide out. But let's graph it. So let me see if I can squeeze it in here. So let me do 0, 0 first. Obviously that's right there. And then we're going to do 4, 1, which would be 1, 2, 3, 4. So 4, 1 is right there. And my line is going to look like so. Okay. Now, these last three are really interesting because they only have x or y. And what you need to recall for this is that what this is really just saying is the collection of x values that are 6. So that just means to go 1, 2, 3, 4, 5, 6. So this is a collection of all values that are 6. So in other words, when x is 6, that's like 6, 0. It could be 6, 1. It could be 6, 2. We could make them negative, 6, -3. What that really means, if I go 6, 0, 6, 1, 6, 2, 6, -3, we can see that all those values just create a vertical line. So anytime you have an x equals graph, you just find it on the x-axis and you draw a line going up and down. Okay. Y equals is the same idea, except all the y values are 3. So we go 1, 2, 3. Now all the y values are 3. So this would be a horizontal line. So just remember, it's a little tricky because a lot of students see y equals, they see y, they think up and down. They see x, they think left and right. But it's, just remember, it's the collection of values that have x is 6. And on this one, it's the collection of y values that are 3. Okay? So again, this would be like 0, 3, and then 1, 2, 3, 3, 3, for example. All right? Last one looks a little confusing, but it's just asking you to divide through by -2, and you get y equals -9/2. This is the same thing. Just remember -9/2, what it is in terms of a decimal. So what I do is I always go back 1 and see what it is. So if I go back 1, it's 8/2. So this is a -8/2 minus 1/2, which is -4.5, right? 8/2 is 4, 1/2 is 0.5. And so I just go to, this is y, so I just go to -4.5, so 1, 2, 3, 4, 5. It's right in the middle. looks like such. Okay? And I believe, yep, that is it. So that is the last problem. Hopefully this wasn't too bad. I'm just practicing graphing, just plugging in numbers. Hopefully you're good with this, and I'll see you in the next video.